Good morning, everyone.
Morning, sir.
How are you?
Morning, sir. We're fine, thanks. And how are you, sir?
Fine. Did you check what the minister is saying? Were you checking the news? What is he saying?
I said no.
Yeah?
Nope.
You didn't check?
Uh-uh.
There was no meeting yet.
Huh?
There was no artist meeting yet.
They
There
didn't
was
say
not.
you're going to address at 10 today.
No,
there was,
sir. She rescheduled
Okay.
to 4:30.
All right. Because it looks like teachers are going to go. I think they said maybe Monday or next week or something like that. Monday, teachers. Yeah.
Yes.
You guys, you're still at home. You only go after the grade 11.
Yes.
Okay. Right. Last time, I think we were looking at physical and chemical change. Then
Yes.
there were two activities that you had there. So I'm just going to explain that. Then we are done with this topic. Then we're moving to magnetism. So I'll go over today's lesson. I'll just go over the chemistry. Then today I'm going to post a consolidation exercise for what we've done. We're going to look at one past paper there if there's time. Then I'll send the consolidation activity. Then in our next lesson, we move on to magnetism. Is that fine?
so
Yes, sir.
Yes, Joshua.
for meeting settings, did you change? How long is the duration of each meeting?
Each meeting is, they give us 40 minutes.
No, there's more than 40 minutes. You can change it.
Because here they give me, what is this? They say according to what, because I'm not, I didn't subscribe. Then they give me 40 minutes. Every time when it says 40, then it cuts. Joshua?
You try changing the settings of the meeting.
Maybe if I have to, schedule another meeting, maybe using different settings, then they're gonna give us more time, I think.
Yeah.
Yeah, maybe I will try that because every time I wanted to make it easy so that people you have only the one way of registering so that you know many codes people end up getting confused. Yeah, but I will try that. Yeah.
Like you can also disable passwords for entering meetings. So once they click the link, they can just join into the meeting straight away.
Or once I create a link, then it won't restrict the time.
Yeah, you have to like set it up properly. Like there's different settings. You just click the default setting.
Oh, okay. I'll check that one and see if maybe we can get more time. Yeah. Okay. Morning, those who joined us later on. Are you fine? Okay. So last time I think we're looking at physical and chemical change. Now let's just go over the conservation of atoms and mass. All right. So there are two laws that you must know. All right. There's the law of conservation of mass and the law of constant composition. So let me just explain what's happening here. All right, so using diagrams to represent rearrangement of molecules during a chemical change, the number of atoms is conserved. Atoms cannot be created nor destroyed in chemical reactions, so that the total number of atoms of each element present at the end of the reaction is the same as the number that we had when we started. All right. The substance present at the beginning of a chemical reaction are called the reactants, and the ones that you have after the reaction called products. All right. Although the number of atoms of each element remains constant throughout the chemical reaction, they do undergo rearrangement. So the number and type of molecule present will change. So you are given there an example: nitrogen. nitrogen reacts with hydrogen, right? So the ratio there is 1 molecule of nitrogen to 3 moles of hydrogen. Then you get your ammonia molecules, right? So that's what you have then. So the number of molecules is not the same before and after the reaction. So as you can see here, you've got 1, 2, 3, 4 molecules. This side you've got only 2 because there's a rearrangement that took place there. So they're gonna be different, right? And this one is also an example of a synthesis reaction in that we start with 2 substances and then end up with 1. So we start with 2 substances, nitrogen and hydrogen, to get 1, which is ammonia. So that's a synthesis, right? So let's look at the law of conservation of mass. What does it say? It says the law of conservation of mass states that the total mass of reactants in a chemical reaction is equal to the total mass of the product. So you guys have to know this, right? So the mass, total mass of reactants is equal to the total mass of the product. Then using the relative atomic masses from the example above, which is the one for nitrogen and hydrogen, we're gonna do some calculations here. How do you calculate? You're gonna check nitrogen, 1 molecule of nitrogen, it's gonna be 14, right? On the periodic table, it is a mass of 14, and N2, so it means there are 2 nitrogen, you multiply by 2, you get 28, right? Then here you only have 1 molecule here, so that's why we're only using 1 molecule. If there were 2, we're going to multiply the answer by 2, but here it's only 1, so we're only gonna use only 28. Then we move on to the next one. You've got hydrogen. A hydrogen molecule is gonna be 1 times 2 because it's a diatomic, so you're gonna have 2. And here we've got 3 molecules, so we're gonna multiply that by 3 to give us 6. Then you add the 2 numbers, 28 plus 6 gives you 34 grams or per mole, or just 34 grams. Then the total mass for reactants is 34. You go to the products. On the products, there are 2 ammonia. So here you've got 2 ammonia here. We need to calculate the mass of these 2 ammonia molecules here, right? So what are you gonna do? The formula there, ammonia is NH3. Nitrogen is 14, hydrogen is 1, but there are 3. So it's 1 times 3, which makes it 3. 3 plus 14 gives you 17. But because there are 2 ammonia molecules, you're gonna multiply 2 times 17 to give you 34. So the total mass of product is 34. So you check, you compare the 2. Reactants is 34 grams per mole, then this one is also 34 grams per mole. So the total mass of reactants is equal to the total mass of products, which means the mass is conserved. So mass before the reaction is the same as the mass after the reaction. That's the law of conservation. Clear? Yes? Right? Then we move on to the next one, law of constant composition. Law of constant composition, what do you have? We have law of constant,